Maybe
Sure
you're muted.
do.
Okay, so there's two things you've got here. Cosine of minus x equals the cosine of x. So that means that this equals the cosine of 3.
When does it like change up or whatever? Like when it's not the not just like making a positive of the function.
We'll do number 2, and we'll get that answer. So sine of negative x equals negative sine of x. So this becomes negative sine of 2.75.
How does that work?
What's that?
Is it just a property or?
Yeah, this is a property. These are it's because it's an even function, and this is because it's an odd function. It's the properties of those things, of even and odd functions. It's just one of those things you remember. I mean, there's nothing really more to it. Tangent of minus 5. So this one we rewrite. It's sine of minus 5 over cosine of minus 5. And from the previous problem, we know that the top one is minus sine of 5. And the bottom one just becomes the cosine of 5. So this becomes negative sine over cosine tangent of 5. So it's not really a property, but you can say tangent of minus x equals minus tangent of x if you want also.
All right.
But that's what the instructor is expecting to see.
Wait, so how do you know if it's odd or an even function again?
Well, there's a lot that goes into that. It's essentially what I just wrote down. Like let me give you some that I think you know as even functions. So for example, y equals x squared is an even function. If you were to graph it, you would see that it's mirrored over the y-axis. Do you see that? And then the way that you test for an even function is you figure out, does f of minus x equal f of x? So in other words, you take this function and you put minus x in for x, and then you simplify it. So here you simplify, and you get x squared, and you ask yourself, is this the original function? And it is, yes. So it's even. So now let's look at an odd function that you know that f of x equals x cubed. This one is odd. It has what's called origin symmetry. So it looks like that. Basically, if you were to rotate it about the origin, you would get the same graph. If you took this part up here and rotated it this way, you get that. Then the test here is does f of negative x equal negative f of x? Okay, so you put negative x in for x, negative x cubed. You simplify, a negative cubed is a negative x cubed, and then you factor out a -1, which it's already done here, but you just sort of do it formally here. And then you say, okay, well, is this the original? And it is, yes. So that means it's an odd function.
Okay.
So that's what's going on with sine and cosine. Cosine is even, sine is odd.
Can you write those out real quick?
That's what's up here.
Okay. I see. Never mind.
This is what you just asked me to summarize. I mean, it's in that reference sheet I sent you. It's useful. Yeah, you just have to remember that for this first part to be able to do it.
That's pretty straightforward. Let's go on to number 4.
All right, sounds good. Snipping it in. All right, so sometimes the instructors call this proofs or verifying identities, and one of the strategies is to write everything, write all in terms of sine and cosine. And what that means is instead of a cotangent, you're going to write cotangent in terms of a sine or a cosine. So that's just a definition. Cotangent of theta is cosine theta over sine theta. If you can't remember that, you can remember that tangent theta is 1 over cosine of theta. And you might be able to go with this direction, or you can remember that, it doesn't matter. So it's cosine theta over sine theta, that's cotangent theta, all over secant is 1 over cosine theta. All right, so secant is 1 over cosine theta. You never want to leave a fraction inside a fraction, so you multiply the top and bottom here by the reciprocal of this, cosine theta, cosine theta. Okay, so on the bottom it cancels, but on the top you get cosine squared theta over sine theta. And there's nothing to simplify, so unfortunately it's almost worse. Your instructor on the quiz will probably give you like cosecant here, because then it'll reduce nicely, or maybe they'll change cotangent to tangent. All right, let's look at number 5. If you have that reference sheet, this would be a good one to have out cheat sheet, because whenever you see a squareds generally mean that you're going to use some sort of identity. Do you have that reference sheet out?
I'm pulling up right as we
Okay,
speak.
I can send you a link if you need it. On page 2 are all the identities. So like the one we're going to use here, I'll snip in. It's 1 plus cotangent squared theta equals cosecant squared theta. So that means this thing on the right here, it becomes cosecant squared theta. This is tangent squared theta. Now you might think to yourself, well, why didn't we put something in for tangent squared? Well, we could have, but generally when you get a 1 plus or a 1 minus, that's what you're looking for these identities. So you're looking for a 1 plus or a 1 minus, and that's sort of your hint that it's one of these. So now let's write these in terms of sine and cosine. So tangent is sine over cosine. So if you square them, you're squaring and squaring. So that's sine squared theta over cosine squared theta for tangent. And then cosecant squared theta is 1 over sine squared theta. So this is times 1 over sine squared theta. And you see this nice cancellation, and gets you down to 1 over cosine squared theta. Now that absolutely can be rewritten, but the instructions say, they say very clearly, just leave it in terms sine and cosine. Although, I mean, I kind of wonder, if you have the answer sheet, I wonder if this is, if they write the answer secant squared theta. Any questions on that, or anything I need to clarify?
I'll look over it one more time. Okay, so that 1 tangent equals cosine squared. So then you turn that tangent into, and cosecant is 1 over. I see what you did there. Okay. That's about, I'm ready for that. Go on to the next one.
Okay, yeah, there's a lot that goes into that, but some of it, it's not all limits. Sometimes it's like, oh, we go off to the side and we do some things, then go off to the next. So cosecant theta is 1 over sine theta.
Mhm.
And cotangent theta is cosine theta over sine theta. Now these have matching denominators. Okay, so what do you do when you have the same bottom? Well, you combine the top
And the bottom?
and keep the bottom the same.
Oh, you don't do anything with the bottom? Okay.
I mean, it's like what's 1/3 plus 5x over 3. You keep the top.
I just 5x over 1 plus 5x over 3.
Yeah.
Okay.
I mean, there's nothing to do here, so that's done. I mean, these are like leading into 7. 7 is, I mean, you're going to get 7 on your test. You wouldn't necessarily get 4, 5, and 6 because what we did in 4, 5, and 6 lead to what you're going to do in 7. Snipping in now. Okay. So the instructions say to verify the identity, and what that means is you choose one side, doesn't matter which side, left or the right, and make it look like the other one. So like this one actually doesn't matter. I would argue they're basically the same. Although, yeah. Yeah. Do you have a preference for which side to work on?
Sine A minus sine B. We can work on let's work on the left one first.
Okay, so we'll work on this side. So whenever you see a squared, you want to think identities.
Mm-hmm.
So the in that cheat sheet there, the identity is sine squared theta plus cosine squared theta equals 1.
Equals 1.
Okay, now that I mean, it's okay. It's great. There's an identity. You have to know how to use it though. So like in the previous problem, we used a 1 plus. You can solve this for either sine squared or cosine squared. So like sine squared theta equals 1 minus cosine squared theta. And then if you solve it for cosine squared theta equals 1 minus sine squared theta. Is that okay? Is that any? If there's no questions, then I can move on. But that's just
Makes
solving
sense.
it. Now these are what are called dummy variables. You can change the variables. So like in your problem, sine squared x, which is really the sine squared x here corresponds to the sine squared theta. So it's 1 minus cosine squared x.
Oh, so you replace. Okay.
Yeah, well, this is 1 minus cosine squared x. Minus, okay, sine squared y, well, that's 1 minus cosine squared y. Okay, so the game here is you generally only touch one side, and you want to make the left look like the right.
Okay.
So, okay, what do we do? Well, we can at least distribute this negative.
All right, so that's a 0 on the left. So now it's just negative cosine plus cosine squared y.
Yeah, you've got cosine squared y and a minus cosine squared x. Put that one first, cosine squared y minus cosine squared x, because they cancel, and then you're done. I mean, when the left side looks like the right side, you're done.
All right, now we're on to the cosine. And we do the same process again, where we substitute that cosine squared y with 1 minus.
No, you only work on one side. You only work on one side. Yeah, when you make one side look like the other, that's how you know you're done.
Oh, okay. Nice.
This isn't a great example because it's usually like you get a really complicated side and then it reduces down to like sine theta or something, and that's I mean, we're not seeing that here, but yeah, I mean, we're just not seeing it there. Well, I guess 8's got a little more to it. We'll do that next.
All right, let's move on to it.
All right. So you have to choose. Am I going to make the left look like the right or the right look like the left? And you generally choose the more complicated side, which seems to go against like everything we've ever talked about. So in this case, you're going to choose this side, the more complicated side. So we got to make it look like the right. And this is where it's like, well, what do I do? So sometimes you take a step and it was the right step, or maybe it was the wrong step, and you got to take another step, or maybe take another step. Like, it's okay to take some wrong steps because you'll eventually get to where you need to go. If the top were 3x squared plus 10x minus 8, what would you just naturally do? Maybe.
If the top were.
Yeah, if it was this thing right here, 3x squared plus 10x minus 8, what might you do?
Was it distribute? Is that what you call it?
You might factor.
Factor.
You might factor here, okay? And that's in fact what you do here. You end up getting this here on the top, but it's not x though, right? It's what is x?
X right here. Oh, it's a 10. It represents 10x. Okay.
It's really sine x. X is really sine x. But you can view this thing up here in the numerator as 3x squared plus 10x minus 8 to factor, but really it's 3 sine x minus 2 sine x plus 4. You have to make that visual adjustment, if you will. It's really to use substitution, but I don't want to emphasize that. It's not, we're not going crazy here. Now, if you're stuck on factoring, you should notice how the bottom looks a lot like the top. In fact, like it's help it like it helps you figure out what the top should be, because it's one of the factors.
So you just simplify this. You just cross them out and you get sine x.
Cross them out, and you're done.
That's it.
That's it.
All right. All right. Let's move on.
Okay. Is there? I don't see a 9. It goes straight to 10.
Okay, so I'll check the classroom real quick. Yeah, there's no 9. It just skips.
Okay. So this one right here, if you go to your trig cheat sheet, this is a sum and difference formula. And I'll remind you how to use this. Let me snip in the reference here. The way this works is that according to this formula here, your alpha is 180 and your beta is x. It's never negative x.
Yes.
You have a minus here in your problem, and that corresponds to the minus here. So these have to match when it's sine. Your alpha is 180, your beta is x. So you're taking this that you have up here, and you're saying, okay, it's sine. Yeah, my alpha is 180. My beta is x. Oh, I put minus there. Cosine 180, sine x. Now, do you get this formula on the exam?
I think so.
Okay, or quiz or whatever. If you don't, I mean, you got to remember, that's one of the things a lot of students get frustrated with, or they're like, oh, I don't want to remember this, but you kind of have to. Okay, now some of this we can simplify. Sine of 180, cosine of 180. So let's review what that is. On the unit circle, your nice unit circle, 0, 90, 180. So it's a nice point on there. What's the ordered pair at this point? How do you get there from the origin? You go left 1, up 0. And cosine is the x value.
Okay.
Y is the sine value. So the sine of 180 is 0. So this is 0 times cosine of x minus cosine of 180 is -1 sine of x.
So plus sine x. So this is cosine plus sine x.
So this becomes just sine x.
Oh, because you're multiplying. Okay.
Yeah, and that's why it says in the instructions, like, rewrite as one term, because it reduces down to one term.
All right. Let's move on to number 11.
All right, so I'm going to snip in the other sum and difference formula. So there's one for sine, there's one for cosine, there's even one for tangent. Again, if you don't get these, they're challenging to memorize because there's little nuances. So in your problem, what is alpha? Maybe you're muted.
Oh, okay. It's 3 pi over 2 plus x. All right.
And your beta is x.
Mm-hmm.
Okay, now you have a plus. Your problem has a plus.
Yes.
And that goes with a minus in this one. Why? I don't know. We can figure that out, but that you just have to remember that it's not the same. Like if you have plus here, it becomes minus. If you have a minus here, it becomes plus. If you're going backwards, it's the same deal. So you're just writing in what you have. So it's cosine 3 pi over 2, cosine x minus sine 3 pi over 2, sine x.
Mm-hmm.
Okay, now again, we've got a unit circle because we got to figure out where these values are. Maybe you get a unit circle. I mean, it's great if you do, just read them off, but we'll do it without it. 0, this is pi over 2, this is 3 pi over 2. So what is the ordered pair to get to this position right here on the unit circle? Well, I'm left or right 0, but then I'm down 1. X is the cosine, y is the sine. So cosine 3 pi over 2 is?
Sine 3 over 2 is 0. No, -1. They have also
Cosine,
sine.
cosine is 0. Cosine's the x value.
Mhm.
Okay. And then sine
Is that
is
negative
-1.
one?
So this again just reduces to sine x.
All right. On number 12. Tangent of 5 pi over 12. How are we going to do that one?
Yeah, it's like, well, this isn't on my unit circle. It's not a nice value. So what you're should have been told is at some point is you can add up certain angles, like the ones that you know really well are like 30 degrees, 45 degrees, and 60 degrees. And you can combine two of these, like you can take 30 and 45, and that makes 75. So that's like your alpha and your beta.
Yes.
You can take 60 and subtract 45 and get 15. That's like your alpha and your beta. Well, what's 5 pi over 12? Well, this one's a little bit harder. So because a number of things, it's in radians, which is already uncomfortable. So let's just convert it out of radians. I don't normally do this, but it's worth considering here. Do you get a calculator on this thing?
Do I get a calculator on this thing?
Yeah,
Or
on this
what?
quiz,
Yeah.
on the quiz. Okay. So the pi's cancel. Give me the value here. What is 5 times 180
5 times 180.
over 12?
It's 600? No, 1600. My bad. That's fine.
5 times 180 divided by 12.
Oh, 5 times 180. My bad. So, let me pull that up. That's 900 divided by 12. And that's 75.
So it's 75 degrees. Okay, so there's a lot of ways to get there, but you generally want to use the ones that are nice. So we're going to think of this as 30 plus 45. So this problem right here becomes tangent, and I'm converting it to degrees, which you may or may not be allowed to do in your exam or quiz, but we're going to do it for that because it's a little bit simpler. There is a sum and difference formula for tangent. Okay, it's a little more complicated, but it's necessary. I mean, it's necessary to have it down. You can just grab it and so let me snip that in here. I just lost it here. So tangent, come on, there it is. All right, so your alpha is 30, your beta is 45. So yeah, this plus goes with a plus up here, but down here it goes to minus. So you have tangent 30 plus tangent 45 over 1 minus tangent 30 tangent 45. Are you allowed to have a unit circle on the quiz?
I think so, yes.
Okay. So in the first quadrant of the unit circle, tangent of 45, it's the easier one. Most students remember this, is it's y over x is always tangent. So it's the y value, which is square root of 2 over 2 over square root of 2, which is 1. Tangent of 30, which is the y over x again, it's 1/2 over square root of 3 over 2. So it becomes 1 over square root of 3, and then that reduces or rationalizes to square root of 3 over 3. So you get those values, that's 30, and you just plug them in. So we got square root of 3 over 3 plus 1 over 1 minus square root of 3 over 3 times 1. So current answer is square root of 3 over 3 plus 1 over 1 minus square root of 3 over 3. So this is correct, but it's not simplified. And from here, there's a lot of things, a lot of algebra, a lot of manipulation, depending on your comfort level. We can go through it or not, but this would not be full credit. This would be like, I don't know, 7 out of 10 points, we'll say. So should I carry on the
Let me,
simplification?
let me check. She gave us the answers. 1 plus 3, 1 plus root 3 over 3 over 1 minus root 3 over 3.
Yeah, and that's what's here.
Mm-hmm. And that's the full answer. You don't need to go further.
Okay. All right. So that takes care of that. Again, those sum and difference formulas, you got to have them down. They're not easy to remember, especially under the stress of a test or quiz. Okay. Next problem here. You might think, boy, I mean, how can I do this? I don't have a calculator. What do I do? Well, it's a sum and difference formula in reverse. So we've snipped them a couple of times, but let me grab the sum and difference formula again for these. And this is where you have to decide, well, which one is it? So you're looking at the right-hand side of these formulas. So is it the first one here, sine, cosine, cosine, sine, sine, cosine, cosine, sine? So it looks like it's this one. Do you agree with that? And that's the sine one. That's the sine alpha one here. So let me just move this one over because it's going to create problems for us down here. Okay. So it's that top one. It's not that one. What is alpha then? Alpha is 76, beta is 31. Alpha is 76, beta is 31. There's a minus here. Minus here goes with a minus here. So this becomes sine 76 minus 31. What does that equal? That's sine of 45. Oh, wait, I know that one. That one's on the unit circle. That's square root of 2 over 2.
And that's the full answer that you wanted.
Yes.
On to number 14.
All right, so 14, the half angle identities go really well with the double angle identities, but what happens is the instructors tend to move really quickly when they get here, and it's so unclear. It's like, wait, half? I thought we did double, and now we're having. So again, the cheat sheet is your guide here. In the second page, top right, are the half angle identities, but you got to know how to use them, and that's what's kind of challenging here. So I'm going to pull up the one for cosine. There's the one for cosine. So you're trying to find the cosine of 105. Okay,
Yes.
so 105 is this part here.
Mhm.
It's saying theta over 2 equals 105. So what
Oh.
is theta? Theta is 210, not 105. So that right there is 210, not 105.
So 1 plus 210.
So you can even write it this way: cosine of 210 over 2 equals plus or minus square root 1 plus cosine of 210 over 2. So if you have your unit circle, you'll see that 210 is right over here. There it is. We want the x value there, and that's minus square root of 3 over 2. So the cosine of 210 is minus square root of 3 over 2. So we have plus or minus square root of 1 plus minus square root of 3 over 2 all over 2. Okay, now there's a bit more to do here. There's a ton of simplifying we can do inside this radical. Maybe or maybe not we have to do it. Then we have to deal with this on the outside. So as where I guess I'll defer to the answer sheet to know how much more to explain. Well, you see what is given there.
Should be on the top, root 2 minus root 3 over, wait, that's weird. So it's 2 minus root 3, and you square root the whole thing, and then over 2, and it's negative. The whole thing is negative.
Okay, so there's a lot there. So let's deal with what the plus or minus here. A lot of times students just guess. What quadrant is cosine 105 in? Or what quadrant is 105 degrees in?
105 goes all the way to the left. So it's quad 2.
Quad 2. All students take calculus. So what's positive in quadrant 2?
Positive in quadrant 2. What is it? So positive. Is it positive, negative. So
No, which of the trig functions are positive in quadrant 2?
oh, trig. I don't
Uh,
remember.
okay, so A means they're all positive.
Yes.
S means that sine is positive, and by sine being positive, the other ones are negative, cosine and tangent. T means tangent is positive. And if tangent's positive, then the other two, sine and cosine, are negative. Here, cosine is positive. That means sine and tangent are negative. You've got to remember this. Like maybe your instructor uses something different between it, but the ASTC is a pretty well-known thing. So 105 degrees is here. So what's positive here? Well, sine is positive here, but you're doing cosine. So cosine is negative.
Negative.
That's how you choose that. Now, inside parentheses, okay, this is really 1 over 1. So what's the common denominator on the top? 2.
Yes.
So it's 2 over 2 minus square root of 3 over 2, all over 2. This becomes minus square root of 2 minus square root of 3 over 2, all over 2.
Mm-hmm.
You clear the bottom fraction by multiplying top and bottom by 1/2. So it becomes negative square root 2 minus square root of 3 over 4. Okay, and then you can apply the square root to the top and the bottom. What's the square root of 4? Well, it's 2. It's a nice one. So it's negative square root of 2 minus square root of 3 all over 2, or sometimes there's a 1/2 out in front.
Huh. All right. And
Okay,
that is the end of that worksheet. I'm gonna send you some pictures of a math book real quick. I'm gonna pull
sure.
out
Let's
the
do it.
answer. Oh wait, I got a 9.3 worksheet right here. I'm gonna pull. I'm going to make a copy of this. I'll send it to you. You should have sent.
Okay, I'll check it out and see what we got here. All right, I do see that. I see it's another copy though of quiz. I got that. I got another copy of it. Maybe it's coming.
Haven't gotten it yet.
No, not yet.
Share one more time.
Oh, well, you shared something. It looks like the same thing though.
Oh wait a minute.
Yeah, it is the same thing.
Oh, I did the wrong thing. Give me a sec. Oh, this is the same thing. I forgot about the other part. Give me a sec. All right, now I found the right one.
Great. I see another, well, I got another one of the same worksheets. Well, no, 9.3 worksheet. Okay, there it is. All right. So you want to work on this worksheet, is that right?
Yes, correct.
Okay. So I'm seeing use the half angle identities to find use the half angle identities to find the exact value of each. Is that right? Okay. So these are more difficult than the ones we just did, but they're just awkward, I guess. All right. So the first one, I'm gonna just write it out because it's formatting weird. Okay, so we got sine of 292.5. So that means that the 292.5 is the theta over 2. So we're gonna double this number. So that's what, like 585. So this is really the sine of 585 over 2. And I actually don't know where that is in the unit circle, but I know we're going all the way around. So 585 minus 360 is 225, and that's a nice known place. That's right there. Okay. So I like to know where I need to know what quadrant we're in, and you do too. So let me snip in the
Quad 3, right?
quadrant 3. We know that sine is negative there. So now let's grab the formula. So both sine and cosine, half angle identities use cosine. Your theta is really, it's 225. It is 585, but because of coterminal angles, meaning you can wrap around, so just want to make sure that's clear.
That is clear.
All right. So we got this is plus or minus the square root of 1 minus cosine of 225 over 2. And so this is plus or minus square root. Cosine of 225, well, that's here. It's on the unit circle, so it's 1 minus square root of 2 over 2, all over 2 here. Okay, so now based on that angle, the 292.5, though, where's 292.5? Well, 270 is here, so it's over here in quadrant 4. Well, is sine positive or negative in that quadrant? Well, all students take calculus. Cosine's positive, so sine must be negative. So we got to grab the negative of this. This is the square root of 1 plus square root of 2 over 2, all over 2. And then there's some simplifying we can do from here. So the simplifying is that you make a common denominator, so you get the square root of 2 plus square root of 2 over 2, all over 2. This reduces to, you bring the 2 up, so it becomes 2 plus square root of 2 over 4, and then you take the square root of the top and the bottom. So it's negative square root 2 plus square root 2 over 2. Do you want us to do
They do all of them?
yeah, or just some of them?
I'd like to go through all of them.
Okay. All right, so next one is sine 337.5. Okay, so we got to double that. That's the sine of 675. 675 over 2. Okay, so that, and then it's the same formula as before. Let me see if I can I think I still got this here. So your theta, see this top number is your theta. So it's plus or minus the square root of 1 minus cosine of 675 over 2. But where is cosine 675? So 675 minus 360 equals 315 degrees. And on the unit circle, okay, where is that? Well, I know 0, 90, 180, 270. So it's right in the middle there. So it's right there on your unit circle, and right in between. It's a 45. So this is really equal to the cosine of 315 degrees. You could look for that ordered pair, but it's the square root of 2 over 2, all over 2, square root plus or minus. So how do we figure out where it is plus or minus? Well, where's 337.5? That's the original problem. 337.5, again, it's 0, 90, 180, 270, so, and then 360. So it's over here in quadrant 4. All students take calculus. Cosine's positive there. That means that sine is negative there. So it must be that negative one.
Okay.
All right, now this simplifies exactly the way the previous one does. So I don't even know if I should go through the steps again, but that becomes that. I'm sorry, 2. It's just like the last one. Okay, now we got, I'm going to do the, well, I guess we need a tangent. Number 3 is a tangent. They throw that in. Okay, so number 3 is a tangent of 105. So again, it's well, wait, I need what theta is. It's 210 over 2. Okay, I can do that. So this one, you've got to go to the reference sheet again, and there's one for tangent. It's amazing how many formulas are in this class. Like it's so formula heavy, but it's the only way to do it. So your theta is the top number. It's always the top number. It's not the original number. It's the one doublet when using these half angle identities. So your problem, it's plus or minus square root 1 minus cosine 210 over 1 plus cosine 210. Okay, so where is 210? Well, go to your circle. It's right there. And so it's minus square root 3 over 2. This is 1 minus square root of 3 over 2 over 1 plus square root 3 over 2. I'm sorry, that one's negative there. Square root and then plus or minus. So determine the plus or minus tangent of 105. Where is 105? 0, 90, 180. So it's over here in quadrant 2. All students take calculus, and you're in the second quadrant. Sine is positive, so tangent is negative. We got another negative again. And then it comes down to like, well, how much of this are you supposed to reduce? Well, if you're taking an online thing, it might accept this. I don't know what your instructor will do.
I think there's was it an answer sheet for this? I can look it up. Let's see. Did she put that in there? Not yet. No. Dang.
You can find this online. You can search for this. This is the CUDA whatever. CUDA software, infinite precalculus. You can find this worksheet online.
Okay. Do you want me to find it right now?
That might not be a bad idea. I need 30 seconds here to deal with something, and then we can do one more problem before we take a break.
Okay.
Maybe more. All right, so number 4 is cosine 105. So again, you really want to write this as 210 over 2 because it does reduce back to 105, but then it tells you what the theta is that you're using. I'm going to snip the half angle formula. These are like the sum and difference formulas. Like if you don't have them, you just no chance. Because you'll just guess wrong, and then it's no way. So this is plus or minus the square root of 1 plus cosine of 210 over 2. I already said that the cosine of 210 is minus square root 3 over 2 over 2. And then we got to say, okay, well, 105 degrees, where is that? Well, 0, 90, 180, so it's over here. All students take calculus, so we know that sine is positive in the second quadrant, so cosine must be negative. Boy, ton of these that are and then this one reduces to you make a common denominator up here, and then the 2 comes up, and we've done this a bunch of times now. So look back if you're not sure, but it comes that over 2 with a negative there. So is your goal to get through the rest of this worksheet in the next lesson? Because we can absolutely do it, but it's very repetitive, and I'm probably going to even look for the one that's
all the answers in it.
Well, just it's formatted poorly, and I'm not going to be able to help as well.
All right.
We'll start back in about 10 minutes.
I'll see you then.
Okay, thanks, Jack.
Thank you. Bye.